Hi guys, we are continue solving our tasks and let's check our road. So we finish with linked list, and next one is would be remove ends node from the end of linked list. So yeah, I already started. It was just not recorded. So let's so let's actually have some implementation here. So we have a head, then we have our next node. So next would be here. Then we just move forward n minus n times, and then we go forward until this next will be not equal to null, and then we should remove actually the from head. Yeah, and here we should have also result. So let's have result, and we return this result. And then we need to have another while loop, and this while loop would be when next not equal to null. We are doing the following: we do head next, and next equal to next. Yeah. So in this case, we need to do this removal operation. So yeah, so removal operation is doing the following. So we are taking a TMP of head next, then head next becomes becomes TMP not equal to null. It becomes TMP next, right? Otherwise null. Or we actually don't need, I think, TMP. We can just do like this. So head next, if not equal to null, then this one, it will be next. Otherwise null. So let's run it. Head equal to head next. So we have 1, 2, 3, 4. So let's sync, and if we have, for example, this one, next not equal to null, -1. Next equal to next, okay. So it should be only one time. So here we should have a head and also a next, right? Then what we do, we iterate 2, then 3, 4, yeah, I think it should be maybe null. So we iterate like 2 times, and then we start moving this one, and then this one, then this one. Yeah, so I think it should be still n. And yeah, so in case of only one node, so next not equal to null, and this one. What if we will check if head next equal to null, and we have only this one element? Can we have n? Yeah. So if we close, then we return null. Yet some works were really slow. So let's use this test case. So we have 1 and 2, and we need to return remove this one. So here next would be equal to null. Yes, so next equal not equal to null, and so we still need this actually logic. What we actually can do here, so we can do like the following. So we have test cases, for example, when n is less than our length, right? So it works. But when n is equal to the length, so usually, for example, we have 2, right? So it's equal to the length. So we can check if n. So first of all, what we can do, so here we can check if next is equal to null. Then we can just return head next. Yeah, so this actually check, it's yeah, compare all use cases, and we see that it's 100%. So let's check how was it implemented before. So we see it's again some dummy node, head, then we iterate. Yeah, and we have the same here, the same here. Yeah, actually the same logic that we already implemented. Also, it's the same runtime. What do we have here? Yeah, also quite complex one. Yeah, actually the same logic that we implemented. We can mark it as done. Okay, copy list with random pointer. add two numbers, find duplicate numbers, revert linked list to, design circular queue, LRE cache, LFU cache, merge k sorted list, and reverse nodes in k groups. So yeah, we have to solve these tasks, and after this we move to the bunch search, and then go to the trees, and after trees we can try backtracking, for example, or we can go to tries heap theme, and and then try to solve some other tasks. So for today, that's all. Thank you.